Hello. Hello, Mr. Mustafa. Now we're gonna summarize our lesson today. We're gonna be giving examples of our own on the board. We're gonna solve them for you. Okay? So from the first lesson, how do you evaluate exponential equation? Exponential power. How do you evaluate the powers? So sorry. 10 by 2 equals to 10 times 10. What's 10 times 10, teacher? 100. What? I'm sorry.
Get this marker.
I'm sorry. Yeah. This marker doesn't work. You cannot see so well. Let me change for you. Number 1. Okay, let's change. 10 is too big. 8 square. 8 times 8 is equal to 56. No. It is 64. 64. Second example is 3 to the power of 4. 3 times 3 times 3 times.
Yes. Sorry. That's okay.
81. There. Okay, so I've shown 2 examples of how we evaluate powers. My next lesson was index laws. So I'm going to show one example from each law. The first example of the first law is AM times AN. Now I'm going to solve 1. 6, 3 times 6, 5 equals to, that one is equals to AM plus N. This is equal to 6, 3 plus 5, which is 6A. And then you evaluate like how I just showed. Let me do it. 6 times 6 times 6 times 6 times 6, 1, 2, 3, 4, 5, 6, 7, 8. That is equal to 1, 6, 7, 9, 6, 1, 6.
So fast.
There.
So good.
That's the answer. And so this can be related to the first one. So if you know how to evaluate power, when you do this law, you evaluate the power and you get an answer. Now I'm gonna show an example of combine the wrong place. I'm sorry. 3, there. I'm gonna show you one example from the second law, which is AM by AN, AM minus N. You like what number? 3? Okay, 3. 3 to the power of 5 over 3 to the power of 7. Now you minus them. 3, 5 minus 7. Oh, that's, yeah. So 3, 5 minus 7 is -2. Thank you. Now if you have a -1, like we have taught you in the first lesson, like I said, you move them up, that will be 3. 1, 3 by 2, that's equal to 1, 9. There. That's for the second one. Now I'm going to give one example from the third law. The third law, which is AM N equals to AM times N. 5, 2, 5 to the power of 12. Now, since it's solving number, you evaluate by yourself. Then you use the first thing I've taught you, how to evaluate power. An example from the fourth law is AB by M. So it's equals to AM times BM. In numbers 2 times 3 by 4. 2 times 3 to the power of 4. That is 2 to the power of 4 times 3 to the power of 4. Now you don't have the same base, so you cannot evaluate the power. Now the fifth one, A by B to the power of M. Put this in number. It's gonna be, let's use one example. Okay, let's make it easy number. 2 by 3 again by 5. So now you distribute. It'll be 2 to the power of 5 by 3 to the power of 5. There. You don't have the same base. You cannot evaluate the power. Now the sixth law, the last one that I taught you. A is equals to A 0 is equal to 1. Now I can give you two examples. 1000 to 0 equals to 1, or 2 0 is equal to 1. Same thing, it doesn't matter on this one. If it is to the power of 0, it is equal to 1. These are all my examples. And there's one more that I've taught you. It's how to change the power from negative into positive. A negative n equals to 1 a by n. Seventh law. Let's make it, why not? And I'll give you two examples for this one. Changing from this to this and changing from this to this. Now, if it's 6, negative 2, like I said, you move it up and it's, it's going to be 1, 6 by 2. Now evaluate this one. Equals to 1, 36. And if it's 1, 6 by negative 2, how do you change it? Same thing. You move it. It's going to be 6 by 2. There. If it's 6 by negative, yeah, there. There.
No, negative 2.
Huh?
2.
There.
It will be negative.
Yeah, there. There. If you move it, there. And in case you have an equation that needs a lot of calculation, like if you have an equation that has 2 and 2, 3 by 2, 4 over 4. In this case, you will need to do a step-by-step calculation. You'll need to start from the outside one using one of the law, which is A, B, M, which is you distribute M to both of them. So in this case, you distribute 4 there and there. And then you times it, and then 2, 3 times 4 by 2, 4 times 4. Now when you times it, it's 3, 12, and 2, 4 times 4 is 16. Now you have the same base. You're dividing the same base. That is the second law, which is to minus the power. So 2, 12 minus 16, that's equal to 2, 12 minus 16 is negative 4. Now, as I've said, if you have a negative exponent, you reverse it, you move it. So it will be 1, 2, 2 by 4. Now 2 by 4 is 2 times 2. How to evaluate power? That's 16. Now so it's 1 by 16. So that's the answer. Like I said, this can come up anytime. This is another type of equation. If you have these kind of complicated equation, you'll need to start calculating step by step. You'll need to look at what law you need to use and then calculate them. And we're gonna give examples of the next 2 lessons that we taught you. And then we're gonna give example of our own for the graph also.
For the next one is exponential power that I'm going to give our own example.
Exponential power.
The root
Rational power.
Oh, rational power, sorry. Rational power, sorry.
There.
Rational power. For example, 3 to the power of 5 root 3, for example. So it will be 3, 5 by 3. As a formula that I gave before, which is a to the power of m root sine by n. It will be am by n, like that. And what if you get the reverse one, like for example 8 4 by 3. If you get like this, so we're gonna write it bigger. 8 4 by 3. If you get like this, you need to do it oppositely, like root 8 4 and 3 outside. The inside is going to be m and the outside is going to be n. So write 4 by 3. And that's it for the rational power. And for the next one is exponential equation. Like 4x is equal to 16, like that. So 4 is 2 to the power of 2. So it will be 2x there, power of 2 there. Because we need to make the base equal. It will be equal to 2 to the power of something is equal to 16, which is 4. 2 to the power of 4 is 16. So now you need to make this and this equal by doing 2x is equal to 4, like that. Divide by 2, divide by 2, cut it out. X is equal to 2, 1, 2, 2. X is equal to 2. That's the answer. And what if we get a harder one? Like this. 9x minus 3 is equal to 27. Like that. Now you need to make the base equal first, which is gonna be 3 to the power of 2x minus 3 equals to 3 to the power of 4, right? Elmona? 4? 327, 4?
Yeah, 4.
4 or 3?
Yeah, 4.
4.
3.
Sorry, 3. There, like that. So now you forget about this one first, because we need to solve. We need to find the x for the power. So forget about that first. It will be equal to x minus 3 equals to 3. So now you move 3 there, negative 3 there. It will be 2x is equal to, if you move there, the negative 3 will be positive 3. It will be plus 3 there. So 3 plus 3 is equal to 6. and you write 6 there. Now you divide by 2, divide by 2. You cut it out. So x is equal to 3. X is equal to 3. That's the answer.
Thank you. None. And the last topic we taught you was how to graph an exponential equation, or the exponential graph thing. And let me tell you one thing. The laws that I've told you can also be called properties. The properties of exponents, or the index laws of exponents. Now we're going to give one example of the graph, and then we're going to end our lesson for today. The equation will be y equals to 3 times 2 power of 2 minus x plus 2. There. And remember, the first step was to find the horizontal asymptote, and in this case it's plus 2. So you write HA equals to plus 2. Y equals to 2. Like I said, not horizontal asymptote is equal to 2. Horizontal asymptote is equal to y equals to 2. Now the second step is finding the y-intercept. So the equation, replace x with 0. So 2 minus 0 plus 2. What is 2 minus 0? 2. 2 plus 2. So it's going to be 3. This is evaluating the power. So 2 to the power of 2 is not 2 times 2. 2 to the power of 2 is, 2 times 2. 2 times 2. So that's 4 plus 2 equals to
3 times 4,
12 plus 2, that's
14.
Now that's your y-intercept. Keep it there. The last step was to pick 2 points, one positive, one negative, and then calculate it with the equation and then plot it in the graph. So x and y, now 1 and negative 1. We'll need to do this. So 3 times 2, 2 minus 1 is equals to 1. Let me write it maybe. Y is equals to 3 times 2, 2 minus 1 plus 2 equals to 3 times 2 to the power of 1 plus 2. So 2 to the power of 1 is the same. Where are you? 2 to the power of 1 is 2. So it's going to be 3 times 2 plus 2 equals to 6 plus 2 equals to 6 plus 2 is 8. Now that's our first point there. Then negative 1. Y is equals to 3 times 2 to minus negative 1 plus 2. That's equals to 3 times 2. 2 minus negative 1 is 3 plus 2. Now evaluating the power, 3 to the power of 3 is 8 plus 2. So 24 plus 2 equals to 26. Now that's another point. 26. Now we're going to graph. Let us count the information we have first. We have the horizontal asymptote here. First step. Second step, we have the y-intercept replaced by 0. Now third step, we have the 2 points we need there. Now we're going to graph. Okay. Now let's graph our horizontal asymptote by dot line. So y is equal to 2, so 1, 2 is there now. Mark it, horizontal asymptote. Second one, graphing your y-intercept. 14. Extend that a bit maybe. And 14. So make it there. 14. And to 8, 2, 3, 4, 5, 6, 7, 8. Let's make it somewhere there. You'll need to be more accurate, but since I have a small graph, 8, and then 26, negative 1, and 26.
There.
No, negative 1, and yeah, 26. It's gonna be somewhere up here. Negative 1 and 26 is gonna be there, somewhere up there. There. So, like I said, our graph doesn't need to always be in one shape. I mean, it will be in a curve, but it doesn't need to be perfect, and it doesn't need to be only in one direction. In this case, our graph is going to be like that. Like I said, it's always going to go very near to the horizontal asymptote of this main line, but it will never touch. It can be 2.0857641 It can be the biggest decimal place to go so near to the line, but it will not touch the line. So this is the graph that we got there, and it looks just the same as the first graph, except the first graph went like that. And like I said, it doesn't need to be in a perfect shape. So to summarize our lesson today about exponential equation, you need to evaluate the power. You need to learn the 7 properties of power, and then there's
Rational power.
And there's exponential equation, trying to balance the base to find the x in the power. And the last one is the graph. Hope you understand and learn something from us.
Thank
Thank you.